Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on partition array according to the given pivot. So till now we have solved the problems where we sort or rearrange arrays using some smart logic instead of traditional sorting. Today's problem is another partition based problem very similar to sort colors which we did yesterday using the Dutch national flag algorithm. So here we are given an array and a pivot. Our goal is to arrange the array such that all the elements less than pivot comes first, all the elements equals to pivot comes then, and finally all the elements greater than pivot comes. So if you consider this example, the given pivot is 10. So all the elements less than 10 are 9, 5 and 3. So initially we got 9, 5, 3. Then the elements equals to pivot 10 and 10, this 10 and this 10, and the elements greater than pivot which are 12 and 14. So the most important part to remember is the relative order must be preserved within each group. In the input array, 9 comes before 5 and after that we get 3. So the order is maintained. Okay. Now for the brute force approach, the idea is we will traverse the array multiple times and we will collect the elements in the required order. So in the first loop, we will collect all the elements which are less than pivot. In the second loop, we will collect the elements which are equals to pivot. And in the third loop, we will collect the elements which are greater than pivot. And then we will update in the result. So let's take a variable n which contains the length of the given input and a resultant array of size n, and then we will take index as 0 initially. So for int I0, I less than n, I plus plus, this is to get the elements which are less than pivot. So we will only consider the elements less than that. So nums of I is less than pivot. If it is, then only we will update result at index. We will increment it later and we will update it with the current element. Now for the second loop, we will only consider the elements which are equals to pivot. Then only we will update it, and in the third loop we will consider the elements which are greater than pivot, and at the end we will return the result. Let's run the code. Okay, it is accepted. So since we are traversing the input array 3 times to get the elements lesser, equal and greater than the pivot, the time complexity would be O of 3n, which is ultimately O of n. And the space complexity, if you consider this array, would be O of n. While this works, we can think better. Maybe this problem is a partitioning problem, just like sort colors, partition by condition. So instead of looping 3 times, we can classify the elements while traversing only once. And since the relative order matters, we use 3 dynamic lists. So let me comment this. And yeah, let's consider 3 lists of type integer. Let's say left, and the second one contains mid, and the third array contains right. Left is nothing but the elements which are less than pivot, mid is nothing but the elements equals to pivot, and right is nothing but the elements greater than pivot. So now we are traversing only once using a for loop, and since we don't need any index, let's use a for each loop and we would traverse. Now if this num is less than pivot, let's add it to the left array num. Okay, else if num is equals to pivot, then we will add it to the mid list. Add of num. Otherwise it will enter into the else block where pivot, where the number is greater than pivot, then we will add it to the right list. Dot add of num. Okay, after coming out of the for loop, we need to update this in a resultant array of size n, and we also need an index. Okay, now we are just merging all the three lists into resultant list. So again we need 3 for loops. Left result of index would be incremented and is assigned to num. And for each number in mid and for each number in right, we would simply update it. At the end we would return result. Let's run the code. It is accepted. Let's submit it. Okay, it is accepted. So when the interviewer asked you to update in a single pass, then we can use this method. So the space complexity would be O of n for all these extra lists which we created. So yeah, let's consider this example. When we enter this for loop, it will first check if the number 9 is less than pivot 10. Yes, so it will be added to left list, and 12 is added to right list, and 5 is added to left list, 10 is added to mid list because it is a pivot, and then 14, 3 and 10. 14 goes here, 3 goes here, and 10 goes here. Now the left, mid and right lists are updated here. Now we need to update the resultant list. For each number in left, so 9, 5, 3 will be added to the resultant first, and we are also tracking the index using this index variable. And then in the second loop, in the mid list, 10 and 10 will be updated. So 9, 5, 3 goes into the list, 10, 10 goes into the list, and in the third loop, this 12 and 14 goes into the list. So yeah, that is it for today's problem, and I'll see you in the next one.